my exponent. My exponent right here for my whole function is x cubed. It's a cubing function. And in your mind, you should say, oh, I know what a cubing function looks like. A cubing function goes like this. Now, when we do this, all your cubing functions, if they're positives, are going to be, and behaviors are going to behave this way. So now we know where our ends are going. So left down, right up. We know that. We know it's odd and positive. That's a good place to start. The second place to start is where are my ends? They're by my zeros. So find your zeros. This is already factored for you. So set them equal to 0. That's because now this is 0. To find your roots, set this equal to 0. Once you do, then I think you'll see your two factors better. So 0, 0, here's your roots. Find your roots. Your left, it goes down. Your right goes up. And you don't have any doubles. Doubles bounce off. If you're not a double, they have to go through. So start like this. Oops. Do we have a double? Sorry, we have a double. This is going to bounce off. This guy's bouncing off. This guy has to go through. So they only can connect up here somewhere. And it's just a sketch. Give me a sketch. You don't, like, unless it's real drastic when you do your max and your min, leave your sketch. You don't have to erase it and make it look longer. It is your sketch to figure out where everything goes. Notice we have no increments on here. So it's a sketch so that we can see it. A lot of times, yeah, it looks like maybe this is higher and these aren't equally spaced apart. But if we made it according to that, our little pieces would be over here, and over here they'd be where you couldn't even see them. So what we're doing is sketching so we can talk about what the graph says. And for some odd reason, I have to calibrate my board again. I should just do this once in the morning. Let's talk concavity for a second. Let's talk concavities. Everybody good with the increasing, decreasing, finding your relative max, your relative min? These are both relative because absolutes on these are infinities. Your concaves, a cave. When you see a movie and you go into a cave, most of the caves look like this, right? They're kind of rounded like this. This is your cave. So this is a concave down. This is a concave up. Think of your parabola. This is your parabola opening down. This is your parabola opening up. So that's the part you want to get. So here's your piece right in here. This guy is a concave down. This one over here, he's a concave up. Well, they share this interval right here. So in order to share, don't you want to share equally? If someone's sharing a piece of cake with you, you say, give me half. So you find the halfway point. Halfway of just the x. You take the bigger half, or you bite the little piece and say, there, now it's equal. So you take the average of the x's. That's all you have to do. That's your midpoint formula. Negative 4 plus 0 gives you negative 4 divided by 2 gives you negative 2. Put it in your calc, second calc, and go number 1 value. Put in your negative 2 and find your corresponding y. We don't use that y for anything else, but because we call it an inflection point, it has to be a point. It has to be an xy. When we do your concavities, your max and your mins are where your increasing, decreasings go. Your inflection points are where your concavities go. So from negative infinity, I'm making a cave down, whoops, right to that point. So negative infinity to negative 2. I still go by my x's. Then from negative 2 to infinity, I'm making a cave up. See it? Whose calc is that? I just use your double. Sorry guys, be right there. And that's it. See it? Okay. Any questions on this one? I need you to be able to describe everything fully here. Is there anything that anybody's having a problem with? No? I happen to like the odd ones better for some odd reason. I think they flow a little bit better for me. Okay, now, let me show you something. Most of you were able to do this one, right? I went around and saw most of you did this one. Some of you couldn't do this one. What's the difference in the equation between that one and that one? There's a fraction, but they're still all factors, aren't they? They still have factors for you. So, when you set this equal to 0, this was the problem. You start like this and you never have a 0 there. When you set this equal to 0, these are factors. Either divide and get rid of that fraction, or multiply by a -2 and get rid of that fraction. If you multiply this by -2, these are factors. So it's just taking this one out. And if I multiply 0 by -2, I still get a 0. So you're already factored. Don't FOIL them, don't combine them. Set your factors equal to 0. Notice both of these are squares. So the square root of 0, both of them result in a double root. You should have 4 roots. You're odd, so 4 roots with an even exponent, not an even function, an even exponent. You're negative, you're down on the left, down on the right. Okay. When you get here, these roots, you start like that. -4, +4. You're down on the left, you're down on the right. Easiest way is a double bounces off, bounces off. How am I going to connect those? Oops, they must loop in the middle, right? I can't make a straight line across there. They must loop in the middle somewhere. And there's my graph. That's a little deeper. And in your windows, remember, here's your window. This is your X and your Y axis. If I can't see something down here, I want to push my window down like this. So with your hand, what are you changing? Which one? Your Y minimum. Anytime you go up and down, that's a vertical, that's a Y. Push your minimum down, make your minimum larger. If it's like really, really like wide and you can't see it at all, go to like -100. Go to -200. You don't care what you set it at as long as you can see a turn. Otherwise, you can't do a minimum on it. Once you see a turn, you're good. If it was up here, this is my Y maximum. If it's here, push your X maximum. If it's here, push your X minimum larger. It's the same as looking at a window with a shade. If I see that little spot here and I say, what's on top of that? I have to push that shade up. I have to raise that Y and go up. It's just your window to your graph. That's all it is. Now, from this, we should be able to tell a lot. We know your relative min. You found your relative min. You found your absolute max. Those are your absolutes. Absolutely the highest point there. We could tell your domain and your range now. We know your range goes from -infinity to 0. We know your domain is all real numbers. We knew that they both went down. Here's your caves. Watch. Just eyeball it. Oh, I see a cave. I see a cave. There's 2 cave down. And uh-oh, I see a cave here. Cave up. They share this. Remember the pattern we followed yesterday. 4 zeros. -1, 3 turns. We see 3 turns. 1, 2, 3. -1, 2 inflection points. Do I have 2 inflection points? 1, 2. And if it helps, and I think you should get into the habit, label your points. Label your points so that you can reference them. So that I also can see where you get your points from. Then your concave down says -infinity. Whoops, stop right there. What's that inflection point X to -2? Up, concave up from -2 to that inflection point, +2. Concave down from +2 to infinity. The only thing we need your Y for in your inflection points is because we call it a point. So a point is an X and Y point. questions on these? You've got to get into the habit. Some of you are barely giving me any work on that page. Follow what we did the day before. I try to give you good examples. I walk through them. I expect you to model your homework the way we model your classwork problem. So get into that habit. Keep that problem next to you and work on it. Okay, here's another one. It's odd. It's positive. So it's following down on the left, up on the right. Okay, we know three zeros, 2 turns, 1 inflection point. So, no? Highest exponent. No, it's odd. It's following your down. It's following your this.
I thought it was something.
Wait, say that again. I don't.
Like, look at the min and max. Sine goes the same, so there's nothing that's even.
Okay. So, good question. Remember yesterday we talked about the exponent being odd and the function being odd. The exponent is odd, but the function is also odd. Because it's not a reflection over your y-axis, it's a reflection through your origin. There's a difference between when we talk about leading coefficient tests. Your leading coefficient tests your exponent. So when that's odd and positive, odd and negative. An odd and even function tests your reflections. So I threw that in there, but I said I didn't want you to deal with it at night because I didn't want to confuse you. But I want you to understand this is not odd function. So now, you factor, you set it to 0. And there's your double root. You've got, oh, no double roots. You have 3 zeros here. So start with your 3 zeros. Go down on the left, up on the right. They all have to come through. There's a -2, a +2, a 0. Down on the left, up on the right. They have to come through because they're not doubles. Now, they also have to come through the 0 point. But you can kind of see the only way to get it is to curve it. There's your steps. Check it on your calc. You have to use your calc for your maxes and your mins. Okay? These are relatives because your domain is all real numbers, your range is all real numbers. So they're relative mins, no absolute mins. You have 1 inflection point. And because you see these, it's a reflection through the origin, right? Halfway through, isn't that at the 0, right? So your inflection point actually is your 0, 0. So you're concaving down from -infinity to 0. Then you changed your mind and you concave from 0 to infinity, up.
The inflection point, that's
And
with the x and y. You take the x and then plus whatever, 0, and then divide by 2.
you take the x's, you add them together, divide by 2. And then put it in your calc to find your y's. Okay? And I think this is your last one. Yeah, it's messy, but when you set this equal to 0, get rid of your fraction. Either multiply both sides by 5 or divide one by 1/5. It doesn't matter. Because now you're an equation with an equal sign and a 0. Set your roots to 0. Because what's surprise? Go ahead.
What does that say under even coefficient policy?
It's an even coefficient.
Yeah, under it.
The right and the left go up. Sorry. That says right and the left sides go up. Now we have 1 double root at the -1. So when you start this, at your -1, that's a double, your 3, and your 4.5. Your ends are going up. And both of them are going up. Now your double root has to bounce off. This can't go through. Okay, here's another root right here. This has to go through. This has to go through. So if you start like that, it's almost like your flow has to be where you don't pick up your pencil. So if I'm flowing with my pencil, it's coming up. I have to continue, go down. I have to continue, go up. And so somewhere like there is my sketch. And when I put it in my calc, I get a little bit better defined there. You have a relative min, you have a relative max, you have an absolute min. Right? And that's how you can also tell your range. You should be able to look at these graphs and tell me a lot about these graphs. Okay, so I start with my highest exponent, which is 4, because this is an x squared, this is an x times x, that's an x squared, x to the 4th. So 4 minus 1, 3 turns, minus 1, 2 inflections. So here's my turns, 1, 2, 3, here's my inflection points, 2. It's got to have a pattern to it. Follow that pattern each time you do this. Good? Questions? No? All right. This is an even exponent, and your coefficient is positive. So where's the end behaving? How the end's going to behave? Both up. Good. Both up. Okay. So start now, like here. Find your zeros. You need to factor. I don't want you putting it in your calc to find your zeros. You need to do this algebraically. What can I factor out of this? I can factor this again, right? To what? X plus 4, x minus 3. Okay, here's your double root. We should have 4. We should have 4 zeros, 3 turns, 2 inflections. Okay, so here's where I start my graph. Here's my 0. That's a double. It's not going to go through. Here's my negative 4. Here's my positive 3. My ends are going up. These have to come through. Okay? This has to meet up with this somewhere. This can't go through. So it's got to go like this somewhere. Somewhere it's like this. When you do it in your calc, you're going to have to change your y min, push it down so you can see where they are. Relative min, absolute max, relative max, absolute min, relative min. Okay, from there, you're going to find your inflection points, and we only have like a couple of minutes. How do I find, okay, this is a 0, 0. Somebody have this point down here, let's call this A. Somebody have point A?
Negative 2.853 and negative 54.644.
Huh?
Is that wrong?
Is that wrong? Did everybody get this?
I got that.
You got that? How about point C?
2.103. Negative 24.211.
2, 1, 1. Thank you. Okay, so now, to find your inflection point, it's the part that they share. Here's a concave up. Here's a concave up. But here is a concave down. There's your inflection at D and E. So 0 plus your negative 2.853. So one of your inflection points is negative 1.426 something or other. 27. Your other inflection point, do the same thing here. Then put them in your calc. Do your concave up, your concave down from that. I want you to finish this one and make sure I see all of those points worked out and the one on the back as well. The one on the back